Hey there, folks. It's Mr. Young, and I'm going to let you in on some of the mysteries of the periodic table. There are all sorts of interesting patterns and secrets in the periodic table, and I'm going to reveal a few of them to you today. Okay, so a lot of these have to do with the patterns of the electrons. Now, you may have seen animations of atoms where the electrons are spinning around the nucleus in these orbits, or maybe you could think of it more like it's three-dimensional, okay? Because an atom is like a little sphere, and the electrons are spinning around in three dimensions, really. But in chemistry, we like to make these two-dimensional flat drawings. And so there's the nucleus in the center of maybe a phosphorus atom, okay? And we could call these things rings or energy shells or electron shells or energy levels or orbits. They have all sorts of names, and these are where the electrons live or spin around or travel. Okay. Now there's a new term I got to tell you about. That is electron configuration. This little code here in your periodic table is called the electron configuration. That means the pattern of the electrons. So 285 means that in the very first shell here, the innermost shell, there are two electrons, just like that two right there. And then hey, there are 8 electrons in the next shell. Electrons really like to be in pairs, but they also like to spread out, okay? So they tend to arrange themselves like this. And then we got 5 in the next shell. So we start at the top, 1, 2, 3, 4, 5. Again, they like to be spread out, but they like to be in pairs. Don't worry too much right now about the particular pattern. Just be able to count how many electrons are in each shell or each ring or each energy level or each orbit, okay? So that's phosphorus. It's got a 285 electron configuration. And you get that information from your periodic table right here. Here's K, or potassium. It has 4 shells of electrons in a pattern 2881. So there's the 2 in the first shell, and then 8 in the second shell, and then 8 in the third shell, and and 1 in the outermost shell. Okay, 1 electron in the outermost shell for potassium. All right. Now, you can be reminded of this by looking at the key in your periodic table. Okay, it tells you this little code here is the electron configuration or the electron arrangement. Now, there's another special term you need to know. That is valence number. Valence means the outermost shell of electrons, or the last number in the code. Okay, so in phosphorus, 5 would be the valence number. For argon, 8 would be the valence number. For titanium, 2 would be the valence number. It's just the outer shell of electrons. Okay, in this potassium right here, 1 would be the valence number, this one outermost electron. Now, the question is, well, why is that special? What's so special about the valence electrons? What's so special about the outer ring of electrons? Well, imagine that we've got a lithium atom here with a simplified Bohr diagram and a fluorine atom with a simplified Bohr diagram. What if these atoms were to bump into each other? Which are the electrons that are going to touch when they bump into each other? Okay, let's have a look. Oh, it's the outer electrons that will touch each other. And this is important for bonding and important for chemical reactions, okay? So now if you look at it, hey, now this electron that wasn't in a pair, now it can be in a pair. The lithium and the fluorine are bonded together. I'll also tell you a little secret. Electrons think 8 is great, and now the fluorine in its outer shell has 1, 2, 3, 4, 5, 6, 7, 8. It feels like it has 8 electrons, and electrons think 8 is great. We'll learn more about that in the next unit, but this is important for bonding. So that's what's special about the valence electrons. Okay, here's another pattern in the periodic table. Let's kind of zoom in and look at some of these elements. Whoa. Okay, let's look at these elements. I'd like you to look and see if you see any patterns in the valence numbers. Take a moment, hit pause. Okay, do you see any patterns in the valence numbers? Patterns. Okay, let's go down below fluorine. Hey, this has 7 valence electrons. Chlorine has 7 valence electrons. Hey, bromine has 7 valence electrons. Let's go over here to Na, to sodium. Hey, sodium has 1 valence electron. Potassium has 1 valence electron. Anytime you go down a column, okay, which is called a group on the periodic table, you will find you get the same number of valence electrons. Things get a little weird here in the middle in those transition elements, transition metals, but we'll learn about those a little later in the year, okay? But generally, for most of the periodic table, if you go down a group, you get the same number of valence electrons. Now there's one more pattern that we're going to look at, and that has to do with the row or the period. Periods are called rows. Rows are called periods in the periodic table. When we're in row number 2, how many shells of electrons do we have? Well, we got 2 shells of electrons in lithium and 2 shells of electrons in beryllium. Let's go to row 3. Hey, the electrons are in 1, 2, 3 shells. 281, that's 3 shells. 282, that's 3 shells. Let's go to the 4th row. Hey, look at that. All these elements in the 4th row have 4 shells of electrons. They have different numbers of electrons, but the electrons are arranged in 4 shells. And if we go to the 5th row or 5th period of the periodic table, hey, we've got 5 shells or 5 rings of electrons in the electron configuration. Okay, so the rows are called periods, and when you're in the first period, you got 1 shell of electrons. Second period, 2 shells of electrons. Third period, 3 shells of electrons. Fourth period, 4 shells of electrons, etc., etc., etc. One last weird little thing about the periodic table. When you get up to element 72, there's this little asterisk, this little star right here, and then you go to the little star at the bottom of your periodic table, and it says basically that this star denotes the presence of 2-8 for element 72 and above. All this means is that, hey, they ran out of room, okay? The electron configurations got so big that they couldn't fit them, and so after element 72, the little dash means, oh, you should just stick in a 2-8 there. They didn't have room for it, and so they're saying, oh, all of the rest of the elements start with a 2-8, and then they end with whatever they give you here. So 2-8-1832-11-2 for tantalum, and 2-8-1832-12-2 for W. Element W is tungsten. Isn't that weird? Okay, so finally, to wrap up, this is called the electron configuration, this little code. The last number in it is called the valence number. That's your outer shell of electrons. The valence electron number will always be the same when you go down a column or a group of the periodic table. And you can figure out the number of shells by figuring out what row or what period of the periodic table you are in. First period, 1 shell. Third period, 3 shells. Fourth period, 4 shells, etc. Thanks for watching. See you back in class.